Hi guys, Assalamualaikum. So let's continue our lesson. So we are going to look at order of reaction. So previously, we have learned that rate equals to K, which is rate constant, times concentration of reactant to the power of order of reaction. So basically X, the value can be 0, 1, 2, 3 and etc. So if the value is 0, kita panggil dia zero order reaction. If the order reaction is first order, so means that X here is 1 and so on. Okay, so this is the definition. We already looked at the definition during the lecture, the first lecture. So, Madam nak sambung sikit saja bahagian integrated rate law. So, basically, integrated rate law is an equation that describes the concentration of reactant as a function of time. So, integrated rate law only applicable for monoreactant only. So, apa maksud monoreactant? Monoreactant ni maksudnya satu reactant sahaja. Bukan dua, bukan tiga. Okay, so basically there are three different equation. There are three different equation. For example, for the first order, this is for zero order. For zero order, the equation is A, concentration of A2 equals to negative KT plus initial concentration. Kalau kita nampak note ni, ini bermaksud initial concentration. Okay, so for the first order, the integrated rate law is ln A, tambah T, equals to negative KT plus ln A naught. So basically, equation ini kita dapat apabila kita integrate this equation. But we don't have to integrate lah. Okay, so this is the final integrated equation that you have to remember. Okay, actually Madam sudah susun this equation according to the sequence of y equals to mx plus c. Kenapa? Sebab nanti nak kena plot graph. Okay, the last one is 1 over a equals to KT plus 1 over A naught. So this is for the second order. Okay, next let's have a look at half-life. Okay, so half-life is the time required for the concentration of reactant. Okay, time required for the concentration of reactant to decrease to half of its initial concentration. Masa yang diambil untuk concentration jadi separuh. So, contoh, if the initial concentration of A, ini contoh, if the initial concentration is 1 molar, so half-life is the time taken for the concentration to become half, which is bahagi 2 lah. So, ini yang kita nak kena cari. Berapa masa yang diambil untuk concentration tu jadi separuh. Okay, so the formula is different according to the order of reaction. So untuk zero order, half-life, ini cara kita tulis half-life, T over 1 over 2. Half-life equals to concentration, initial concentration of reactant divided by 2K. So nak senang ingat, ayam ada 2 kaki. Ayam ada 2 kaki. Okay, next for the first order, half-life dia adalah ln 2 over K. Okay, ln 2 over K. For the second order, half-life dia adalah sama dengan 1 over K times concentration of initial concentration of reactant. So yang ini nak senang ingat, satu orang berkaki. A apa tadi? A adalah ayam. Ayam ada dua kaki, satu orang berkaki ayam. Yang ni ada idea tak kita nak sebut apa? Comment down below. Okay, next. This is a graph of concentration against time untuk first and second order. So untuk zero order, okay, so when we plot concentration versus time, you should get straight line graph like this. Okay, dan okay, so let's say lah kita nak cari, let's say here is the initial concentration. Madam letak 1 mole lah. Okay. So maksudnya kalau separuh 0.5 lah kan. So berapakah masa yang diambil untuk dia jadi 1.5 tu dekat sini. So basically itulah first half-life awak. First half-life. Masa yang diambil untuk dia jadi separuh. Okey, so sekarang 0.5 ni kita bahagi lagi 2. So kita dapat 0.25. Dia decrease another half. So masa yang diambil, awak ambil pembaris, baca dekat graf awak dekat sini. Okay, so basically this is the second half-life. Okay, kalau kita tengok jarak antara jarak ni, yang ni kan macam luas berbanding yang ni kan. So we can conclude that. First half-life yang pertama adalah 2 kali ganda untuk second half-life. So maksudnya kat sini contoh, kalau sini 20 saat, so yang sini 10 saat. So nilainya separuh daripada yang first half-life. Okay. So itu cara kita tengok graf untuk half-life. Okay, so for first order, you should get graf melengkung. And untuk first order, let's say the initial concentration again is 1 molar. So kalau separuh, kita dapat concentration 0.5 lah kan, macam tadi. Okay, and you pun gariskan, dapatkan time dekat sini. So this is your first half-life. Okay, so untuk first order, we can conclude that first half-life sama dengan second half-life. Maksudnya kat sini, if the value here is 10 second, so here also 10 second. Dia sama. Okay, so itu untuk first order. And last one, untuk second order, dia punya half-life. Okay, second half-life dia adalah 2 kali ganda. Tengok kat sini ya. So this is the first half-life. Okay, and the second half-life is here. So kalau kita tengok nilai dia bertambah 2 kali ganda. So second half-life lagi besar 2 kali ganda berbanding first half-life. Okay, so maksudnya kat sini, if the value here is 10 second, yang second half-life mestilah 20 second. Third half-life lagi tinggi, 30 second, and so on lah. So itu perbezaan half-life. Okay, the graph of half-life between zero, first and second order. Okay, move on to the last one. Okay, linear graph method. So we can know the order of reaction by using integrated equation tadi. Okay, so sekarang salin balik integrated equation tadi. Okay, sekarang ni Madam bagi tahu tadi kan, I already arrange the equation in terms of y equals to mx plus c sebab kita nak plot graph. So kalau kita tengok untuk zero order dekat sini, the gradient belongs to negative k. So bila plot graph nanti, graph awak adalah negative slope. Okay, so now this is the graph for zero order. So when you plot, okay, concentration versus time, you should get negative slope. Okay, slope tu gradient lah. And then dekat sini adalah y-intercept awak, which is initial concentration. So daripada graf tu macam-macam yang you boleh dapat. You boleh dapat nilai K, you boleh dapat initial concentration. Okay, so untuk first order kita akan plot ln versus time. So again, slope kita, gradient kita adalah negative K. So nanti when you plot the graph, the gradient is equals to negative K. And the y-intercept is ln A. So kalau soalan nak cari zero order, nak cari initial concentration, so kita dapatkan daripada graph lah. Okay, last one. This is for second order. Untuk second order, dia positive slope. Nanti, so gradient dia adalah sama dengan K. Kita akan apply matematik punya formula. Kalau kita nak cari slope ataupun gradient, kita akan gunakan formula y2, y1 equals divided by x2, x1. Okay, dari situ kita boleh dapat nilai K lah. So, and then the y-intercept here belongs to 1 over initial concentration.